it is even in kilometers, hundreds of kilometers. So that's why you can see here these communication happen through WAN, satellite, and various mode of communication. Mostly these kind of systems, the SCADA, typical SCADA is used where there are operations are very expanded. The industrial operations are geographically expanded from one corner to other corner. I mean, from one part of the country maybe to other part. So this is all about. But if you see the attributes are quite similar to what distributed control systems are. And this is the Purdue model. So while we say the fundamentals of the OT operations technology, system comes one of the key element, that is the industrial control system. And if we see the Purdue model, which is of course as per IEC 62443 is also one of the reference model, and industries are following, particularly the critical infrastructure and hazardous environment, they are strictly following this Purdue modeling. So in this Purdue model, you can see defined level 0 to level 4, but it is further expanded to level 5, level 6. We are going to currently discuss the reference model, which is up to level 4. So what is level 0, level 1, 2, 3, 4? And this DMZ, you can see DMZ is also called as a L3.5 in between level 4 and level 3. So level 0 to level 3 is the core process control entities or process control network. Level 4 comes where the particular organization or industrial enterprise system comes in picture. While I say the enterprise system, it is connected to intranet. It is internet, but it is, you can say, the privately managed thing. So it is not as vulnerable, but yes, it is still connected to the internet. It is an enterprise. And this is why you can see it is segregated to the demilitarized zone. Basically, it is created as a buffer in between level 3 and level 4. Now, what is level 0? Level 0 basically contains all our physical devices. So in the physical devices, there are sensors, there are valves, there are the physical devices. Even our process equipment which is getting controlled comes under the physical devices. There are the other kind of mechanical devices, mechanical valve, rupture disc, we have the pressure relief valve. All those comes under the things, but level 0 particularly contains the component of industrial control system, which is the sensors, transmitters, valves, etc. While it comes to the level 1, so you have seen the distributed control system in the previous slide are similar to safety instrumented system, which is another high-end PLC. So these particular input outputs, whatever it is getting received from here, the CPUs, so the complete brain reside in the level 1 actually. And this is one of the key to monitor, control, and safeguard the process. This is the key brain which is receiving the input from the level 0 and coming to level 1. And after level 1 processing, it have the brain, it has the built logics, it is processing, and it is further communicating back to the field whatever kind of instruction is needed to control the devices, what kind of outputs is needed. On the top of it, there is a supervisory control which comes to the level 2. This is where our operations engineer, operators are there, which is interacting directly with across whole the physical processes, which is expanded even in the kilometers. Sometimes they are sitting and monitoring, controlling, and safeguarding from this level 2. Then level 3, of course, level 3 is further expanded. At the level 3, it comes even the engineering center, engineering stations, lot of other servers. Those things resides in the level 3. DMZ, as I say, it is created for the buffer zone. This is up to level 3. It process control code stops, and then level 4 comes. In level 4, there is many other business application comes in picture. There is a plant information system, there is a laboratory management system, logistics management system, and number of systems are there which is processing the data for day-to-day business proceedings, supply chain, financial management, HR, and a lot of other stuff. But many information, process information is needed for these days, particularly to have the optimal business operations. For example, the plant information system, laboratory management system, logistics management system is needed the data. But however, these interactions happen through high-end deployed firewall, nowadays the new generation firewalls, which allow the traffic from here. Usually preferred traffic is unidirectional, one way. Nothing is usually written back here. There are certain applications, for example, uh, advanced process controls or some other applications which needs to have some write access, but then there are different mechanism. If we need to do those kind of bidirectional communication, then what sort of things to be in place in this DMZ? So DMZ is one of the, you can say the name itself is telling the demilitarized zone. So now you can see in the right hand side, the same things what I explained is just referred here, respective component, which I have already explained. In the TMZ, you can see those applications are there which interacts through intranet or internet, and you can see the interface communication in between process control, this pink zone and the green zone. So this is how about the Purdue modeling. Coming to the components of IT, I hope everyone is very well aware the what about the information technology. It have the typical hardware which contains servers, workstation, routers, softwares, firmwares, application, networks. In networks, of course, the LAN, WAN, VPNs, virtual private networks, data storage, security. So this is the typical. Even in our enterprise, these systems are getting used, and cybersecurity for IT is nothing new, but yes, for OT, it is something we will deep dive why it is important. So this is all about the components of the IT. Now, what is the key difference in between information technology and operations technology actually? So one of the key difference you can see in the right hand side that there is a triad, and the fundamentally information technology security itself is based on the CIA triangle, which is the confidentiality is the topmost priority. Of course, the integrity and availability is the one of the third one. But while it comes to the operations technology, the availability comes first. So it is basically AIC. Even though the expanded definition is SIAC, which we will discuss. So CIA and AIC as per IC 62443, which is silently included that while it is telling availability means safety is part of it, but this definition is further expanded by the NIST, which says the CIAS and SIAC means the safety first, of course, the safety, integrity, availability, and the confidentiality. So the core difference is the priorities of the both of the technologies are different. One side where IT focus the topmost priority on confidentiality, other side our process industries are the highly sophisticated hazardous industries. Main focus is people, environment, and assets. First they have to look into them and then to produce, manufacture whatever they want, and the system should run, business should go. So this is the key difference. And then of course you can see there are differentiation where the life cycle of IT is 3 to 5 years, which is one of the painful area is getting in the OT side. Every 5 years, the particularly the component associated vendors are coming and telling, hey, now your system is needing upgrade because your particular OS is now having another version with security patches. So these 3 to 5 years, while it is written 10 to 20 years, this is a typical CPUs, cards, etc. But it is no more in reality remains 10 to 20. If you are operating the asset, then you know that those component every 5 years typically we need to upgrade. If not, then you have to have very well planning of the life cycle. Then the downtime, it matters in the OT. Even the few hours, couple of hours or few hours downtime is a matter of millions. But sometimes in IT, it doesn't matter. You reboot the system, take in line, and all those. So uh, this is where another key difference comes. And while we will dive through more on those things, the patching and other things, then you will understand the pain, how it matters. The patch management, even in my organization or in your organization where you are working, you are getting one notification while you are working that your PC need to start. Maybe in 1 hour are you scheduling? It's okay. I mean, while you are getting to stop the work, you will reach some patch is there. Then needs very well planning. It cannot be simply that, hey, okay, restart the plant. No, it cannot be. And this is where the key difference comes. Then, while it comes to the focus, already we talked about what is the top focus, whether it is SIAC, the safety and availability is the top most focus while it comes to the operations technology. But data protection is the top most priority for the IT. Protocols, of course, nowadays, even the many IT protocol is getting used in OT. It is nothing like remains this, but yeah, the typical OT protocols are there, which is particularly used. It is a Modbus, of course, DNP3, OPC, Ethernet. There is physical layer protocol, for example, field bus, Profibus, and many other protocols, industrial protocols. So on the protocol front, OT becomes very unique while it comes to the below layers. Of course, on the above layers, it have the intersection with IT. And this is making unique because you have a different unique protocol. Few protocol built years back, maybe 30 years back, 25 years back, which doesn't think about security. It thinks just about how optimal plant can operate, how the data can be available. And if still those legacy systems are running in today's industry, that becomes a threat in today's environment that we will speak in further upcoming slides. Why do we need the security, particularly the OT security? So the answer is very simple, because our ambition is increasing. Our stakeholders' expectation is getting very high. The way the technology is disrupting, the way technology is changing, transforming, you itself can feel if you are part of any particular industry or process, or they are your customers, or some way you are interacting with one of the stakeholder, how their expectations are changing day by day. So be it they wanted to put some new tools, new software, they want to have a prescriptive analytics, they wanted to have more analyzed data, and many other things, even the digital dashboards. The top management want to see just in one dashboards everything and make decision. This is happening and this is getting matured. So what is happening at the end? Earlier, these things were even maybe 5 years back, these things were not in that much of demand. But the way technology is changing, the way competition is increasing, um, one can be leading those technology, or one can just look but cannot ignore, because this is the future of tech. So basically what we are doing, we are getting connecting more and more, we are enforcing more new technologies. But unfortunately, today many of our assets are legacy assets, which is 30, 50 years old, but we wanted to compete with those who are getting top notch. Like if you build a new infrastructure today, you can build. But if we have certain infrastructure which is years old and we wanted to do that, that is creating a threat, that is leading to the threat. So this is why we need to have the OT security. And being the legacy asset existing, this is much more vulnerable, because each particular asset, X company with Y organization or Z organization, each is having their own design, their own deployment. There would be different type of industrial control system, different devices, and those different systems might have different gaps, different security threats. It cannot be like one solution for all. So basically, we need to understand that we are on risk if we are going ahead along with evolving technology. Of course, if you are not doing anything the way you were operating 30 years back, you are on the same. Okay, it can be said that still you are fully isolated, you are not doing anything, but this is the fact that we are not remaining the isolated. So ultimately, it's all about the risk management. There are certain incidents we will see in the next slide. We have a dedicated slide. Just here it is put some name because these are the key incidents which happen in the industrial sectors. Okay, colonial pipeline, you can consider it is not typical OT incident. Of course, it happened at more on the enterprise level, but most of the other incidents which happen, yes, it has the direct impact to the industrial environment. But we will have deep dive in the next session. Okay, why we need the OT security, we had already discussed. It is the similar things, but one of the key regions today across the globe is the legacy system, which is the older system. uh, the hardware is become sold. Even the, okay, we wanted to upgrade the software, but due to limitation of hardware, many times we are not able to do. Or many times, even if we are able to do, there is some other kind of interoperability issues are coming. So there is a number of issue while it comes to legacy. I think we can have another dedicated session on this. This is another deep topic. And of course, the threat landscape is increasing because of the set reason earlier. If we are very much motivated to adopt the technology, we want it to the next generation operators, then yes, we have to embrace the threats which is evolving along with those. So basically, these are the criticalities which we talked about, the priorities of IT versus OT. So the topmost priority is the people, environment, our assets, while it comes to the OT. Because OT, as I say, it is itself is built on the three pillars, which is process itself, the technology which is used, and the people who are operating in it. And it is a huge resource required, the sophisticated process involved, and technology is evolving day by day. It is not only the core process technology, but also the technology which is supporting from the back or front end to these operational technologies. So coming to the real world incidents, so you can see the Stuxnet. Many of you might have listened, if not. So Stuxnet is basically is called one of the first time in 2010, which is first known cyber weapon which is utilized on the industrial sector. This was basically, it was targeted incident to nuclear centrifuge uh, by manipulating the CPUs of the particular PLC. So PLC is basically what we talked about, the BPCS or DCS. So PLC is the similar entity which is used to control the facilities, and it is compromised. So the source of compromise was, of course, the external devices. So this is one of the key element and one of the key things to take care of while we are doing the hardening. But yeah, so the Stuxnet, after Stuxnet, the Samoon was happened first time in 2012, then again happened in 2016, and further it happened in some Italian oil company. Basically, it is a kind of uh, first time it happened through some sort of phishing email, which wiped off. You can understand the magnitude that in GCC it happened, one of the biggest oil and gas industries, which wiped out almost, reported, what is this from reported sources, 30,000 computers. It is such a huge kind of impact was. The similar was happened in second time again to the similar facilities, and then to other Ukrainian power grid attack, which is also very well known, and it it has created a complete blackout for certain thousand hours. I don't remember exact figure, but it was a huge blackout because of this incident. It was happening in Ukraine, and it was a geographic motivation. You know, the Russia Ukraine even nowadays is ongoing. So earlier, before this war, there was a cyber war. So as a part of those cyber war in 2015 and 2016, this cyber attack was. Then Tritron or Trisis, it is called, it was the core key element of the safety PLC, which is called the emergency shutdown system, or it is called the safety instrumented system. This was very shocking because this was a very sophisticated attack, which is called advanced persistent threat. It is well planned, highly motivated, very sophisticated resource utilized. So this is another incident. This was also happened in Saudi Arabia in one of the very renowned safety instrumented system, which is called Triconics. This is why its name is the Trisis. There are many more, but these are the key incidents. And then, of course, the sectors has realized that yes, whatever it is, but we are, you can see which is something is demonstrated, its impact is huge, which is going up to the level of asset, people, environment, means it is a huge impact. And this is why we need to take care of the operational technology security. This is just from here we will just have a quick glance about the security life cycle in line with IEC 62443. So basically there is a three phases as defined by 62443: access, implement, and maintain. So basically, as I discussed in the previous slide, each particular asset, industrial asset, plant, or environment is unique. So if it is unique, if it is different make, model, technology, etc., one solution built tailor-made solution cannot be. And if someone is telling, means it is unfair. So if you are entering in OT or you are OT professional, so one thing you have to keep in mind that for sure, if we are thinking about the OT security, then we must have to have the access. What access? We have to access what is the baseline and what is the gaps actually. This can be depending on the various factor. One of the key factor is risk appetite, the risk portfolio, the threat intelligence, a lot of other things. But we need to know where we stand with reference to our own benchmark, with reference to standard benchmark, or with reference to any other benchmark where we stand in terms of security. Once we know that, then it comes to the countermeasure. If the gap is identified, basically there is two terminologies. One is the gap assessment, which is the high level. Then we go the deep assessment, which go in quite fragmented assessment. So first we go as a high level assessment, first to try to close those big holes, then try to cover the smaller holes across the things, because as I say, the assets are years old. We cannot keep everything in one go. So this is the strategy. Then of course we have to maintain. It is because the things are evolving, even the threat landscape are changing along with the technology changes, not only along with technology changes, but along with the maturity life cycle of the deployed the particular softwares, firmwares, OS, etc. So these are the three phases in nutshell, which is important, which also defines by IEC 62443. While it comes to the NIST, that is another standard which framework says to identify, protect, detect, respond, and recover. This is another framework, the NIST 882. Likewise, IEC 62443, this is another. And nowadays, there is a lot of collaboration is happening in between both, that what is the commonalities and how it can be come to the optimal level of intersection. But if you see in nutshell, a lot of things are having the commonalities in this framework. First, to identify, whether it is gaps or what kind of countermeasure is needed, then apply it, protect, then also monitor it. You need to detect it, then of course to respond, recover, etc. We are not deeping in down. This is just a basic framework. As I say, we can have another session for this. Defense in depth. So this is again both of the framework, be it NIST or 62443. The unlike the IT, the operations technology, it is given that we can protect the things not only by the cyber security, but also the physical security, personal security, and cyber security. So, as I say, it is a, like a cyber physical system because our industry is complete physical entity. So we need to make sure that how is the physical security. While it comes to the physical security, lot of things comes. How is the access? How is the access control? Lot of other things, CCTVs, many other things comes while it comes to the industrial physical security. Then of course the policy procedure, while it comes to the both, of course IT policy procedure, but then OT policy procedure. Nowadays organizations are getting matured on this journey of the policy procedure. It is not very old, but since few years the organizations are preparing a dedicated policies and procedure which fit for the operations technology. Then Jones and conduits is one of the conception. While we have seen in the previous slides of the Purdue modeling, the layered approach, one of the key purposes we can very well segregate, can define the particular zones, conduits. If it is highly secured zone, we can put in that way, we can isolate in that way. If we need to put data diode, if we need to put new generation firewall, industrial firewall, etc. Then there are other ways around the malware protection. There is antivirus, there is whitelisting, there is other tools which is getting deployed. Again, while we say the whitelisting or antivirus, it is not exactly like what is typically doing in the IT, but this is usually tested by these legacy system, by these legacy vendor. They are checking if it is fully uh, compatible, then only it is getting deployed. The purpose is the latency issue shouldn't come. The whatever speed of data transfer is needed, it should work, because in industrial sector, in particular operations technology, it is a matter of even milliseconds. We works on the 100 milliseconds, 200 milliseconds of response time, and this is what makes it more unique. So whatever system we are putting in place, we have to make sure that any of the control, our control loop, our process control is not getting impacted because of these deployments. Then of course the access control, while it comes to the access control, we have of course the physical access, but also the logical access control. There is other type of protections. Monitoring and detection is another sort of things. There is IDS, IPS, and all those sort of things which is getting deployed to respective layers. uh, Most prominently level 3, level 3.5, yes, but nowadays even in places which has been seen, if the people are planning and putting to the downline, but it is very carefully with well planned manner. But to lower levels, it is mostly getting avoided so that it can be detected at higher levels of the Purdue models. Patching, patching IC 62443, one particular part itself is defining a dedicated technical report, which I hope very soon are is converting to the standard. There is a dedicated way of patching. There is a complete life cycle of patching in OT. The identification, the testing phases, the deployment phase, the stakeholders engagement. I think there was one very famous incident recently. One of the, I think, airport, it was impacted badly. Um, there was some sort of issue was highlighted. I don't remember exactly the name of this, but what I'm trying to highlight here is the patching is very crucial because it also demands maybe reboot, restart, or sort of response time. if it is getting impacted. So these are the sort of things, if you see the layered approach, which is getting, even while we are doing the hardening of our existing infrastructure, so we are taking care that these layers, what we can optimally do as a first hand to minimize the gaps and to secure the processes. These are the key standards. These are the particularly standards you can see for the cybersecurity, which is of course the IEC 62443. While it comes to ISA 99, basically the IEC 62443 is converted from the ISA 99, the parent organization being the ISA 99. Then the National Institute of Standard Technology, NIST 882. Then there is other series, then European Union Cybersecurity and UAE National Electronic Security Authority. These are the key OT cybersecurity standards. But then there is a sectorial standards. There are certain key aspects nowadays while we are designing the plant, we are designing the industries, we are trying to take care of if there is any sort of intersection and how we can make smoother during the design phase, during the engineering phase. Then there is electric sector, there is a dedicated standard, NERC, for sure if people working in the electric sector will be knowing. So these are the few key standards just for the glance I have put, which is used for cyber security as well as for particular security, sectorial security. Now, just this is one of the slide because by profession I have been almost 20 years in the industrial environment since the start of the career. So the pain of the these particular OT security is evolved, as I said, in maybe last 1 decade. Quite this because of the change of the our expectation, stakeholders' expectation, and the technology changes, etc. So, what is the problem? The problem is the impractical in many industries, many entities, it is getting failed. While we start this initiative, uh, be it consultant, be it designers, we should be taking care that ultimately we are running a business which is running since years. So if we want to do everything over a day or just a quick fix, it is not possible. So we need to go in the phased manner, we have to go in the systematic manner instead of just putting the tiny detail and make such a huge project that it don't become the feasible, that because we have to take care the process and plants operating, but we have to see how optimal way we can manage in the phased manner and looking the priorities of the risk. Then many times stakeholders, as I say, doesn't able to realize that there is trade-off between the risk and the cost. While we are driving this factor, we have to take care at the rate of what cost, what we are trying to achieve. If we make a very good business case, which is millions of things with downtime of 1 month or two, and we want to make a product and our a project, and we our business case is down for maybe a weeks or months, this become very challenging. So we have to be really practical enough while we are driving through the business case. We have to see the trade-off in between, that how and what we are driving in, what is our risk level, what is our priority. So we have to look all those, and looking all those, we have to have the sense of our industry, our environment. We have to feel what is our operations, our people are feeling, what is their priorities. We cannot keep these business cases in isolation. Then coming to the procedural driven, of course, I mean, sometimes I have seen in few of initial project, like I have got a checklist, hey, this is the mandatory requirement you have to follow. What is those mandatory? Very nice checklist. Okay, you put everywhere the new generation firewall, you put all the defense in depth, everything, but it is not going to work. We are not sitting here to make a checklist. We have to have the access what exactly, if we don't know what in our environment is there, what we have put in, what kind of risk it creates, maybe the risk is negligible, then why those mandatory checklists? So we need to assess, we need to feel the pain, the risk, what kind of worst risk it could lead to, and then we have to frame the solution. And so these are the important points which I itself have felt in my own journey. So if you are entering in the OT and you want to drive it, so you have to look those practicalities and those challenges from the eyes of one plant environment engineer, instead of just sitting in the office and thinking typically from the way the IT project goes. Then another key challenge, the supply chain. While I say supply chain, you have seen there is n number of entities is getting interface, and there are manufacturers, there are suppliers, there are system integrators. Each have their own responsibilities, but ultimately there is asset owner. There are owners of the system who are operating the plant. So this is the ultimate responsibility to make sure from where we are sourcing the material, what type of processes they are following to build their product, to test their product, to deploy their product, or to, most importantly, the life cycle support their product. So the life cycle, the supply chain becomes very important while it comes to the operational technology security. And there is a dedicated framework, there is a dedicated definition. Even IEC 62443 4-1 and 2 defines very well how you can mitigate this supply chain risk. So these are just few key challenges which I thought of to put in front of you, being work in industry and being in my continue journey of this OT cybersecurity. So with this, I'm ending my session of the training. Now floor can be open for the questions, interactions, etc. Thank you so much. I'm
Thank you,
audible?
Amit.
Yeah.
Yeah, Amit, you're audible. Thanks so much. Before you answer the technical question which is coming up, there is one question, a general thing which has been asked by most of the participants. I would like to answer that. Uh, People are asking that they are getting the PPT and the recording. So answer is yes, we will be sending it to you after the training is accomplished. Thank you. Over to you, Amit. There is some question. You can take it one by one. We have a little bit delayed, so we have to take it quickly because the next session is about to start.
Yes, so can you please elaborate, because I'm not sure if I can access these questions from here. Just 1
You can first stop the screen sharing.
minute. Yes, that's what I'm trying to. Yes, it is a stop. Uh, okay, how you supposed to secure the legacy system? Yes, I think Sovic has put this question, and rather this is one of the great questions, because see, the legacy system security, it is not one single answer how to secure the legacy system. The single answer, if I have to give, I will only give: you have to know your own system first, and then after knowing the gaps, after knowing the what kind of uh, greatest security risk you can mitigate one by one, because there can be a number of type of issues, but you can attack with own priorities by looking, assessing it, what kind of security risk is there. In certain cases it is challenging, whether it need to be replaced, migrate, or what, but yes, it has to be tailor made, followed by the risk assessment. Is there any guidelines for IEC 62443 for deployment in just 1 minute? Deployment defense in depth? Yes, there are guidelines, there are standards. So basically, if you look IEC 62443, 3-3 is basically the system security parts. So if you go to the system security parts, it is going to give quite reflection, but there are various parts, but the system parts give the quite good design criteria in terms of the security. Then sorry, me to run through. I think Rakesh, let me have look other. Okay, training on IC2 certification. Please let's know whom to contact. Yeah, so basically, if you want to IC 62443, there is n number of certifications, various organizations. Of course, one of them is ISA. Then there is Exida, there is TUV, even the particular today's session. So basically, it needs what kind of certification you need, what is your purpose. According to that, you can take through based on your purpose. There are also the certification with a lot of cost is involved, time is involved, so you can decide what fits and suits for you. Then what is the key difference in IT and OT, which I already explained. The safety and availability is the key consideration criteria for the OT, and for IT, of course, the confidentiality. ICS and automotive cybersecurity similar, they related to this field. See, the while it comes to the of course the sectorial things can differ. Process industries security is yes, I can whatever I have run through, even the Purdue model and other things those, but in automotive it can be expanded more because they have quite a lot modular things. So this can certainly differ, but the key pillar standard, I think the key could be the quite things can be the intersection in between. Abdullah Al Shahid, thank you for a great session. Could you please share entry level
Thank you, Amit.
goals? Yeah, I
And
think there
because
is
of
another question. If time doesn't allow, maybe we can answer because I can see many other questions are there.
yeah,
We can answer to those. And if somebody is raising hand and directly interact, time allows, they can. Otherwise, we can switch to the next sessions.
yeah. Thank you so much, Amit. We are running short of time, and we have already another speaker plan for this session. We will get back to all the questions which you have sent us. I will share it with Amit, and once we got back the answer, I will share with all the attendees. Thank you so much, Amit.
Thank you.
Uh,
Thank you. Yeah.
Now I would like to ask Zakir. Zakir, please could you start the session? I know it's very late, and please let me know if you had any problem while sharing your screen or you need me to share any polls for you. Zahid,
Mm.
can you hear me?
Yeah, yeah, hello.
Yeah.
Yeah, I have
Thank
some
you, Zakir.
problem,
Over to
but
you now.
it's only allow me to share all the screen, but wait a bit. Yeah, let's go in this way. So do you see the screen?
Yeah.
Yeah, okay. Yeah, welcome everyone. And thank you for joining today's webinar on ICS network architecture and protocols. So my name is Zahar Benhart, and I have more than 10 years in OT cybersecurity. And whenever you're an OT engineer or IT security or just getting started, industrial cybersecurity, this session is designed to give you a foundation and understanding on how ICS networks are built, how they function, and how we can protect them. So a little bit agenda. So we will start with what ICS networks are and the key components inside the networks. So we will go through network layouts and a little bit touch the Purdue model, the different network layers and their roles, the common security issues and how to address them, and core industrial protocols like Modbus and OPC UA, and how we can connect them with our network. And the first question is, what is an ICS network? So we talked last hour little bit about the Purdy model and how everything is connected, but what is inside the network? So we are starting from the operational components. It's more or less like PLC, air tools, some sensors, actuators, and our brain that devices which are doing the most important part and the keep live processes. After that, so we have networking, like switches, firewalls, to make these communication paths, so to connect all the devices together and make it secure. And after that, of course, the workstation, it's like engineering, operator, HMI. So the screens which are controlling the processes and our operational layer. And of course, the SCADA, data historian, all the servers which are growing and growing in modern architecture. And we have more and more business requirements to connect and to send data from the network, OT network, and to the network. So it's more and more complex. And the second question is, why ICS network architecture important, and why it's matter? So first of all, it's reliability. So ICS environments demand uptime. So if a system goes down, you might lose millions in downtime, and of course, it can create unsafe conditions, which is unpredictable, which is cannot be in our networks. First one is security. So it is segmentation, access controls, and proper monitoring can prevent or limit damage from the cyber attacks, because now we are connecting all this legacy or new system into IT, into business, into the cloud, internet, and etc. And security is growing more, and you need to make it properly. And maintainability, so it's more a clean, logical network is easier to troubleshoot and to scale and to make it in work condition. And of course, safety, it's number one. So we need to make prevent any unintended commands and reduce risk, because we are working not with data, but with people and with processes and with real environments. And what we are talking today, this is a high level of the network. I want to show you how to build the network properly, maybe a more structured way, and how to do it in easy way. So we are not going deeper into the Purdy model. Yeah, we will talk with levels, but more or less we will talk about how we are connecting the devices. Why? Because, for example, if we are going into the Purdy model from level to level, there is missing levels such as DMZ, or people are trying to create more deeper level like 2.5, 3.5, and every network is unique, and it's hard to make it in the same industry. For example, in the grid, you cannot make it the same in the different plants or companies. So we will go in more network view, not the Purdy model. But yeah, of course. So what we have level 0. This is all these physical processes like field devices, your valves, motors, sensors. Yeah. Okay. Next one is, and I tried to map it into this network to have a comparison. Level 1, it is more intelligent devices, PLC and controllers. Level 2, it's control systems where the HMIs connects to the PLCs. Level 3, it is more operational systems like SCADA and data historian. Here we have a DMZ. It's more or less modern thing that you need separate the IT and OT. And the upper levels, so level 4 and upper, it is more business, logistics and more business. And we will go one level by one. What we are talking about levels as a network layer levels. It's not Purdue model levels, but the network levels. Why? Because it's easy to draw the network and easy to understand where is my, for example, PLC or HMI connected. So, for example, level 2 is there the real-time control happens. So, in this level, devices often share the same broadcast. So, we don't have a routing. It's more or less industrial switches without any routing, only with MAC and broadcast communication. And in this level, we see the HMIs, the PLC. It's more or less like local control of the plants, for example, for field devices like valves and some switches. And yes, we are not going into deeper into the field devices because for newcomers and for understanding, it's not necessary to go so deeper. So for here, we are talking about that level 0, 1, and 2 from the Purdue model. It's more or less which is connecting into the level 2 switch, because you will have a level 2 switch in your network. This is where we can say that this is the control network. And we are focusing here on the local processes and devices which are connected into this switch. Sorry. And of course, the purpose of this is it's local monitoring and control. So it's operator access to the process data and can manipulate with PLC or HMI locally without the central layer. Next layer is free layer. So and the problem from the Purdue that we are connecting two levels from the Purdue, it's control and manufacturing operators. What is here? Here we have level 3 switch. So it's where the routed network connecting. So we have IP addresses, routing tables, and the systems which are more centralized. So it's more or less focused on the plant-wide monitoring and the devices connected into the level 3 switch. So it is their operator station or engineering station or SCADA or historian. So all the devices which are connected into the level 3 switch. And unlike the level 2, level 3 networks are routed. So we have real segmentations with networks, with firewalls, and more intelligent devices are sitting here. The next is DMZ, and here the problem of Purdue it doesn't exist there, but we need this one. And the question here is not how many firewalls you are putting into the DMZ 1, 2, or 3, or 4. You need a DMZ. This is the things that all servers, all jump hosts, all updates, everything that which is connecting into IT and OT must be intercepted in this DMZ. And the key purpose is to prevent direct communication between two systems like IT systems and sensitive OT layers. Here is located, for example, host jump servers, update mechanism, or data transfer tools. Also, if you are managing some patch delivery or vendor access, these interactions also should be stopped in this DMZ. And the upper IT level, this is level 4 and 5 for Purdy model. It's all these IT office networks which are like ERP system, quality control, or business intelligence. So these systems need some data from OT, or you need to send some data into the OT from these systems. And of course, this is the most critical and first entry point for all the cyber attacks or all the problems. So it's also very critical to have this in your network map. And before maybe we are going next, we can make a poll. Can we run it? Rakesh, because I have a screen.
Yeah, I will do it. Mimuna, can you run that poll about third question?
First question: how segment is your ICS or OT?
No, the next one, protocol. Zakar, you can mention which one you want to run.
About the network, yeah, in which level we are sitting.
Okay, all right.
Okay,
The second one then.
how segment is your ICS and or
Yeah.
OT? Okay.
I hope everyone can see this poll on their screen. Last time some people were not able to see. Thank you, Rai. Thank you for confirming. Thank you, Rajesh. So all the technical questions will be answered toward the end of the session. There is a question answer session. Mimuna, some people are not able to see the poll. Is it any way we can do something?
Maybe we can wait a minute, because normally when someone is having internet issues, they could have a delay in seeing the screens. I think it's visible on their screens. If they go back and just shut their screen and then turn it on, maybe they would be able to see this.
Okay. I hope the screen share is a full screen visible to the participant. All right. So this is 2 minute is over. Let's close the poll and continue with the presentation. Zakar, you can talk about this output of the poll.
Yeah, okay. Do we need to analyze the pool, or we are going next?
Yeah, so around 51% vote for fully segmented zone. 26 is partially segmented. 7% is for flat network, minimal isolation, and 16% are not sure. So accordingly, you
Yeah.
can drive the presentation further. Thank
Uh, yeah, and this is why you need to start from the basic segmentations and to understand where your systems are presented. So it may be more easier than to go deeper into the zones and to separate, because it's hard to understand where is PLC in zone 2 or zone 3, but you need to draw this diagram like this one, maybe starting from the simple one, and you will see where your first one, where your systems are located, so where they are connected. So are they on the level 2 switch, or are they on level 3, or on the DMZ? At least with this segmentation, you can start think next steps and doing next steps. And this will be, by grouping these devices, it will be reduce risk by limiting access and containing attacks to these devices. You will group the similar devices, and the next thing is that you will draw a controlled communications, which devices are talking with which devices. This is also a very important part. Without this, all these sort of segmentations are not working. And of course, good segmentation also makes it easier to detect anomalies or problems. If something not working in your network, you can understand it more easily when you have all this in documentation. And for example, as an example, let's talk about remote access. When you have draw the IT or office workstations and draw the DMZ with your servers, you can draw the connection that you have RDP from your office or remote access laptops or PCs to your jump host. And you are drawing this connection by RDP, and you can analyze it, who need these, which are requirements for these connections, and maybe, for example, access limited to specific IPs. And as a requirements, do you need a VPNs or multi-factor authentications? And of course, you draw into your jump host, not drawing directly to your level 3 or level 2 devices. So this is important. And when you draw this red line into level 2, it will also raise a lot of questions why you are doing this, and it's more easily to understand and to prove and to create firewall rules at the end. And after you draw all your connections and all your services and paths, so you will have this, for example, threat modeling, or understand, in this example, vendor. Which vendors do you have, in which system they are going, and how they are connecting to these systems? Or you have engineering laptop. So how this laptop is going into your switch from like how is this laptop monitoring under the monitoring, or can you connect this laptop into the internet? Or do you have USB sticks? It's more or less not a network communication, but also you can add this into your network and think more easily. And of course, you will draw all these IT DMZ connection, DMZ to L3, L2 connections, and etc. And once the network is mapped, it's easier to find entry points and find the problems, or to document these services for future, and to talk properly with IT teams, OT teams, and security teams. And of course, what we can do with these networks, so we can implement strict network segmentation. So you are segmenting your network more and more every step, or draw an architecture where this segmentation is documented and working. And of course, control and monitor remote access, because nowadays all the modern OT environments required for remote access, but you need to be very careful of it and draw all these RDP connections. Of course, use strong authentication methods, regular update and patch systems, of course, which are not critical and located into the DMZ, for example, jump hosts or whatever, not critical and located in the net, not in the level 2, you need to patch them. Limit the removable media or whatever devices that are not documented and can easily break all your security measures and all your segmentations. With one router, with one USB, it will be break everything. And of course, monitoring network traffic and train your staff and your engineers. This is main or maybe measurements. And yeah, before we are going and connect the protocols into this presentation, a little bit a quick mention here that I will use the example from the LabShock. It is the let's say first industrial cyber lab for hands-on, and it's a great way to simulate all these protocols, network connections, and to understand how your devices are connected and what is running inside your network. And maybe before we are going into the protocol, we can run the second poll about the protocols.
Yuna, second one, please. Yeah, all right. It's running. So people are working more with Modbus. Yeah, no, it's changing. Waiting for more votes. Yes, friends, we want everyone to vote. So
Yeah,
Profinet is the
Modbus is
least one people are using. Yeah, 60% done.
yeah, Modbus is still the most used protocol. So and we can go further on. We are waiting.
Yeah, just another 20 seconds
Okay.
and then we'll close the poll. So till now the result is Modbus. Everyone is majorly using Modbus.
Yeah. Okay. And
Right,
this
over.
is why Modbus is here. So, and how the ICS network architecture and protocols are connected. When you have this physical diagram, where you are putting all your devices for like a Purdue model or whatever model you want, it's really not so important. You are drawing these connections with protocols, so which services are running inside your network. And once the services are mapped, it's easier to find like best firewall rules or best architecture, or to know that between level 3 switch and level 2, between SCADA and PLC, we have a Modbus. And when you document this, you can detect anomalies and detect all the bad protocol and bad traffic which is going into in your network. And what we are talking today, we will go in summary, like for this one about the protocols, and we will stop in the Modbus as the most used protocol, and which is, of course, simple, widely used for PLC, HMI communications, and etc. in one way, and in another way it is very old and without any security. So, and all other protocols are pretty much similar to Modbus. They are fast, they're easy, simple, but no security there. And the second modern protocol, let's say, this is OPC UA, where you have more secure communications. And I think that all modern architecture must use the OPC UA or similar things where you have at least security by default. And for all the industries, you have this DNP-free for grid and water, and EX standard with a lot of protocols inside, which is also used widely, or Profibus, Profinet, some proprietary protocols for some real-time automation. And we will go in about the risks of the protocols, what we have in all these, let's say, legacy and old style protocols. This is first is lack of authentication. So most ICS protocols don't verify the identity. So you can send any command from any device to your PLC and it will accept it. So there is no security inside. The second is no encryption. So data often sent in clear text. Yeah, it's good to maintain and good to analyze or good to monitor, but also any device inside your network can read all your data and build the exactly the network topology and network diagrams perhaps better than you have in your documentation. Broadcast and unicast by default, so easy to sniff or reply messages. Protocol misuse, so normal commands can be used for harmful action. So any read, write, or whatever command which your SCADA can send to the PLC, another device can also send, and the PLC will use it. And of course, legacy design. Protocols were built for reliability, not for security. Yeah, of course, we can say that for some critical systems, we cannot change the protocols and we must run Modbus. Yeah, in this case, you need to make real segmentation inside there and protect your Modbus or monitor your Modbus or make some measures to reduce the risk. And most common protocols, I choose one Modbus as a legacy and OPC as a more modern things. So the Modbus is usage for PLC to HMI level 2 or SCADA to PLC level 3 communication. So you can connect different types, not only bottom layers, but also SCADA PLC communication, more upper layers. And of course, not Modbus, but all this legacy are simple, like slave master, client server, and there is no built-in security. Yeah, there is some add-ons for Modbus, like secure Modbus, but who is using it? Maybe you can write on the chat. We can make statistics or whatever, but it's rare. And of course, it's dominant in legacy systems, and our poll is we agree that our users is also using Modbus in their networks. And another one is OPC UA, which is going to change OPC old one for DCOM communications, which are unified, standardized, and have encryption, authentication, and all these things. And yeah, it's mostly using for SCADA or historian communication or OTIT communication, more upper layers. But many PLCs, for example, nowadays also include their OPC array support for OPC array in their PLCs. And it's more secure, interpolate, support complex data models, objects, and etc. And it's more scalable and more modern, let's say. And let's start from the Modbus, maybe a little bit history. It's from 79 years, so it's far away by Schneider. It's simple, lightweight, and it has different versions like R2, ASCII, TCP. Most of us using like Ethernet. And common use cases, of course, reading data from the PLCs to connect to PLC and read the data, or write the data into the PLC, or SCADA R2 communication, and of course integrating legacy devices. So it's more or less 4 commands which you can use to handle all these logic. And about the logic, so it is master-slave model. So we have one master which initiates all requests like query, and slave only response to these queries. So it's not event-driven, it's query and responses. And I draw the main function codes, like 4 of them, which are using most of the use cases. So it is read coils, function code 1, function code 3, it's for read holding registers. So in this case, coils is a boolean 0 or 1, and the registers it's temperature or whatever integers. And we have to write these coils and to write these registers. And with these 4 commands, you can easily manipulate with PLC. And not only the SCADA can manipulate with PLC, and every device which are in your network, which you try to draw, can manipulate with this PLC if there is no segmentation. And this is the problem and connections, these protocols with our ICS architecture. And here is an example as a Modbus with a read coil. So what we have on the traffic. So we have a query. Our SCADA, let's say, goes to the PLC and read the coils. We can detect the packets, and packets is unencrypted, and inside the packets there is a Modbus, let's say Modbus data, which are at the end, some bits at the end. We can see the function codes, and of course the addresses which are requesting and which is reading from the PLC. And after that, the PLC sends a response for function called read coils. He's sending the states of his coils. Like, for example, here we have one bit in one, so something is enabled, another is disabled. And if you're sitting inside your network, you can detect and draw all these maps for tags and for values and for all your PLC, let's say what PLC is storing. And this is the real problem. And if you are connecting these systems, legacy old systems, into the new world, for example, you are connecting into the cloud or whatever, and if you have access here, it is a very big problem, and you need to think about segmentations and think about how to maybe replace Modbus or somehow secure it. And the same is going for registers. So registers have, let's say, more data on the packet, but on this case we have some, of course, function code free, and registers like here we have 50, so something with 50, we don't know what it is, but we know that something store 50. Here is 0, 0, 0. So for every address we have the data. And if we will collect all this information, we can easily at least understand what is operator doing and how PLC is how PLC interact with this data. The second one, write coils. And here we can see that we have only two, one query and one response. So our SCADA is sending the query to write coil, and of course the PLC is making response with write single coil. And we are sending the function code 5 with the data FF00, so it is 1 in the encoding. And the most worst case that your PLC will not somehow check this data, it will write this single coil into this register. And he's responding that, yeah, I'm writing this coil back to your SCADA. And in case how to secure this Modbus, it is a big question, and this is why we have OPC UA, like more secure protocols which will replace old ones. And with modern systems and architecture, like I strongly recommend to use modern protocols, not to stick to OPC, to the Modbus, and after that think how to secure it. And of course, this is old OPC, but like old OLE for process control, but it is unified architecture. So everything is under unified solution. It developed by OPC Foundation, and it is replacing these OPC COM based protocols. And it's protocol independence, and of course support some Ethernet and all these new systems. And we have here like architecture is a client server and pub sub model. So we don't have this query and response only when something is changing. You have a subscriber and publisher, and you are sending the data. It's more scalable and more structured data models. And what we or as a security professionals see here, that it is encryption and authentication with certificates, usernames, and authorization. Here it may be not supported by old PLC, but new PLCs are running this without any performance problems or CPU usage or whatever. So it's not a problem. This one, and of course, features, use, and adoption. So it is used in modern SCADA, HMI systems, IoT devices like industrial IoT devices, and cloud integration, and it supports so many features. It enables like true convergence for IT and OT. And of course, we need to push this into to make secure protocols inside our ICS network, because otherwise all these trying to make micro or nano or whatever segmentation, if you will have bad protocols inside, it's also not so good. And as a summary, maybe I can say that first, draw your network physical diagrams where your devices are connected. Yeah, maybe it's hard, but you need to do it. And after that, put there the paths and connections for protocols, for services. And try to, of course, segment your network. At least make a DMZ with some number of firewalls, and to understand and know your protocols. Because if you don't know the protocols, someone else will know your protocols better than you, and it will be a big problem. So yeah, that's all. Maybe Rakesh, we have one more poll there, and after that, make some questions.
All right. So basically, Mimon, I can put the next poll. This poll is basically a surprise gift from Zakar to our audience. This is basically a hands-on session lab shock.
Yeah.
Based on you people, your preferences, we will try to get this hands-on session from Zakar, where you will be having a deep understanding of this tool and how it's going to be useful in your OT cybersecurity journey.
Yeah, and this session will be more hands-on and real-time. We will go into the protocols like Modbus and check in real-time how it communicates and how the devices are communicate with each other. Yeah.
Sure. And friends, one more thing. The final dates and details about this session, we will be broadcasting on our LinkedIn channel, which many of you have already subscribed. I request whoever is not like our channel and follow our channel basically to get the updates on this session and many more coming up in future.
I need somehow stop the sharing.
Okay. Okay. So tentatively dates are 12 July. Let's see then. We will discuss internally and we'll publish the
Yeah.
information on the on our channel, official channel. But yes, there will be a channel. Over to you, Sakar. You can continue.
Yeah. Yeah. Stop sharing. And maybe we have questions here. Thanks. Can you provide some theoretical material pre-requirements about the protocols before the hands-on? Yeah, of course. We can do it like a list of list of all protocols and about the Modbus and what we will touch in this session. What is more preferable between level 2 and level 3 switch or a firewall? It's depend one more time about your network and your architecture. If you can put the firewall there and can manage it, yeah, put a firewall there. So I saw this many times that you have a level 2 firewalls which are make segmentation of your level 2 and level 3. Protocol standardized by industries. Here, some industries like Grid in US or another ones, medical protocols are standardized. So there are more or less for each industry protocols. So what is a LabShock? LabShock is a virtual industrial environment to simulate your network and communication between SCADA and PLC. It is a pre-installed and ready-to-use environment to make these investigations and detections and attack scenarios that you can run inside your environment, locally running in your machine. We want now the encryption technology for each protocol and its impact on the network. Little bit don't understand the question. Sir, how I'm supposed to set up lab for my own practice? Any guidance from your side? Guidance it's not so complex. It's easy. You can find in GitHub or in YouTube. There are videos how to set up it. It's 10 minutes. Okay. What's your view on data diodes and firewalls together? Yeah, my view on data diodes that they must be hardware and very simple, and you need to use it in really strict and critical infrastructure, but not making from diodes inside the diodes a lot of logic, and your diodes will be as a firewall. So it's bad to maintenance and the cost question and etc. So okay. What is impact of AI on OT security? We will see, but impact is what we have in all others, let's say, technologies and industries. It will change the OT. Can you use the same firewall for OT and IT on different ports? Of course. Same firewall, what do you mean? You can use one firewall to separate your OT and IT and make DMZ. So you will have three interfaces, external, DMZ, and internal to put into a firewall. Or you can put two firewalls, one IT firewall for IT team, next is going DMZ, and after that OT firewall for OT team and with internal communications. One more question, please. Working through your levels, 60 levels. Will completing them prepare me enough to apply the job? It's more or less I'm focusing on the SIEM, OT SIEM direction, but of course it will give you a lot of information about attacks, about protocols, and there are also labs which you can use with LabShock. So yeah, it will definitely prepare you to some questions. At least you can check how to configure the detection rules or some Zeek or ideas, or we'll know this architecture what we talked today. Can we change on the lab inside the LabShock to make my own automation process? Yeah, the LabShock was built in mind that it is modular and you can change it and tune it to your industry and to include, for example, the hardware PLCs. And people are doing this way, like running OpenPLC on the Raspberry and connect it to the LabShock. So yeah, it is the yeah, and we will schedule the hands-on session about LabShock. So we will continue this hands-on trainings to test it in real time and to learn this Modbus by heart because it's more than 60% usage in the ICS. Yeah, thanks for all. I think I answered the main questions. So.
All right. Thank you so much, Zakar. For the previous session, the answers, since time was short, it was given one-to-one on the chat. I hope that everyone has received their answer for the previous session. Now, there is important thing which I want to tell every one of you is that everyone is going to start the journey in OT cybersecurity, or they have recently started the journey. So, tomorrow we will be looking for some feedback from you people about the topic on which you want the further or the new sessions in coming months or coming years. Okay. So based on your feedback, we will going to make the session available on our channel, and we'll keep you all informed. But tomorrow there'll be a poll, and you have to mention about your topics which you want to run on this session. So yeah, that's it. And Mimon, do we have the quiz after this event? I think you will be receiving some quiz after this event, and request you to please answer those quiz as well. So with this,
Yes.
we will finish. Mimuna, it's now over to you.
Thank you everyone for attending the session. I hope you have find this session informational and educational. We will try to share the presentation as we get from the speakers. We will send you it by emails. Once I shut down this webinar, you will get a quiz which consists of 10 questions. Once you answer those questions, we will be able to assess your understanding about the session, and we will be able to disseminate the certification upon your responses. Thank you everyone, and hope to see you tomorrow. Bye.
Thank you, everyone. Thanks.